In the last tutorial, we talked about how a nerve impulse travels along an axon. We call that axonal transmission. Now we want to talk about synaptic transmission. Well, first of all, what's a synapse? The synapse is this little space between a neuron, and in this case, this is an effector, but it could also be a different neuron as well. So it's a little space. And we call that little space the synaptic cleft. Okay, it's only about 20 nanometers, very small. You can see this in the electron microscope right here. This little space right here. Okay, this neuron is called a presynaptic neuron, and this part would be the post synapse, the after. And we're going to go through the different parts of this in a moment. So there's my synaptic cleft. And again, this is a diagram in your textbook. The action potential comes down, in this case, to a terminal motor neuron. And as we're going to see, vesicles bubble up, and these neurotransmitters diffuse over and cause an action potential, a depolarization on the postsynapse over here. Okay, the postsynapse on this side. So synaptic transition, how does a signal move from one neuron to another or to an effector like a muscle? The action potential will not move across the synapse. More synapses, slower transmission. So reflex arc has few, so it's pretty fast. Neurotransmitters are chemicals that diffuse across the gap, and they're released by the end plate of the presynaptic neuron to the postsynaptic neuron. And this diagram outlines all of these processes. There's just a larger figure of it. Impulse travels the synaptic cleft. Vesicles move and diffuse across. Neurotransmitters are released. Neurotransmitters bind to receptor proteins. There they are on the other side and cause depolarization or hyperpolarization. That's what we want to look at next. So the action potential reaches the end plate. Calcium ion gates open. Okay. Calcium causes release of acetylcholine. You need to know this neurotransmitter. Acetylcholine is released and it binds to sodium channels on the postsynaptic, and this causes it to depolarize. Action potential continues through the dendrite of postsynaptic neuron. The presynaptic end plate membrane releases choline esterase, which is an enzyme which breaks down acetylcholine, and the neuron transmission stops because the sodium gates close. Neurotransmitters like acetylcholine can be excitatory. So ACH is one we've already looked at. Acetylcholine is excitatory. But you can also have inhibitory ones that cause hyperpolarization. Now, some other common neurotransmitters other than acetylcholine are dopamine, causing pleasure, serotonin, mood, appetite as well, endorphins, painkillers, norepinephrine, fight or flight response. So this is used in the peripheral nervous system, autonomic nervous system. And GABA is an inhibitory, it's a natural tranquilizer. Well, a lot of research has been applied to these. Depression and serotonin reuptake inhibitors like Prozac, they inhibit the reuptake of serotonin. Well, serotonin affects mood. So if you take Prozac, you now have more of these serotonin molecules in the synaptic cleft. They do not get taken back up into the presynapse. Here's my presynapse. Here's my post. So they stay in here. Normally, these reuptake transporters would take the serotonin and bring them back. Well, if you've got more in there, your mood's going to improve. You notice with people with depression, they have low serotonin levels. Cocaine and dopamine. It blocks the reuptake of dopamine. Well, dopamine makes you really happy, right? So you snort your cocaine, there it is. There's the dopamine. Look at what cocaine does. It prevents the reuptake of the dopamine. Normally, dopamine will go back into the presynapse. Cocaine blocks these, okay? And now you're flooded with dopamine. Okay, give this a read. It's quite interesting. Lots of problems with that because when you've got too much dopamine in here, the dopamine receptors on this start getting lots and lots of dopamine receptors. Well, if you've got lots and lots of dopamine receptors, when you stop taking cocaine, this neuron doesn't fire very easily anymore because you only got regular amounts of dopamine coming onto them. And you have physical withdrawals. Unlike, say, marijuana, cocaine will give you a physical withdrawal. You become addicted to it physically. Summation. Effects produced by the accumulation of neurotransmitters from two or more neurons. They can be excitatory or inhibitory. Presynaptic action potentials result in either excitatory or inhibitory synaptic potentials. Now let's take a look at this. A is excitatory. That's a neuron coming into a second neuron. B neuron is excitatory, but C is inhibitory. So when all three of these fire, A is excitatory, B is excitatory, but they're not enough to cause the neuron to fire out all or none. C causes hyperpolarization, but when we add them together, a threshold is reached and the neuron fires. This is very important for things like walking, coordination, which is a combination of excitatory and inhibitory. Okay, it's a combination of them that gives you subtle movements and nerve control. This is just a diagram showing the same thing. Inhibitory would be C, but when we take A plus B, it's enough to cause an action potential. Okay, let's try this question. Please use the following information for the next question. An experiment was conducted to examine the relationship of neurons W, X, and Y on Z. W and Y, W, Y. X, X plus Y. Okay, which row correctly identifies excitatory and inhibitory neurons? Is W an excitatory neuron? Well, the microelectrode recorded the membrane potential of neuron Z. The graph illustrates. So when, note, dotted line indicates the times when the neuron were stimulated. So when neuron W stimulated, neuron Z depolarized. So we would say it's excitatory. How about Y? When neuron Y stimulated, it causes depolarization. So neuron Y is also excitatory. How about X? When X stimulated, it causes hyperpolarization. So the best answer I see there is C. Okay, you've got this project, cut and paste this out. This is the second part of this where it just goes through the different parts and you can double check that you've got these right in here. Skip number 8, too much information. Number 9, we've talked about, and the enzyme. We're going to use the example of acetylcholine as a neurotransmitter here. So we're going to make the triangle acetylcholine. Okay, a few questions I want you to try. These are good practice problems. And then I want you to do the workbook pages 1 to 5, plus the fold out, the foldable. That's good. And then textbook questions, page 384.